I am Fathima Raniya, third sem computer science, and I'll be discussing about IR sensors. An infrared sensor is an electronic device that measures and detects infrared radiation in its surrounding environment. That is, an IR sensor senses the infrared radiations that are surrounding to it. And IR is invisible to human eye as its wavelength is longer than that of visible light. Anything that emits heat gives off infrared radiation. Now, there are two types of infrared sensors: active infrared sensors and passive infrared sensors. Now, let's talk about the working principle of IR sensor. An infrared sensor includes two parts, namely the emitter and the receiver. So, this is jointly called an optocoupler or a photocoupler. Here, IR LED is used as an emitter, whereas the IR photodiode is used as a receiver. The photodiode used in this is very sensitive to the infrared light generated through an infrared LED. The resistance of photodiode and output voltage can be changed in proportion to the infrared light obtained. This is the fundamental IR sensor working principle. Different types of IR receivers exist based on the wavelength, voltage, package, etc. When used in an infrared transmitter receiver combination, the wavelength of the receiver should match with that of the transmitter. The emitter is an IR LED and the detector is an IR photodiode, as we have discussed before. The photodiode is sensitive to the IR light emitted by an IR LED. The photodiode's resistance and output voltage change in proportion to the IR light received. This is the underlying working principle of the IR sensor. Below is a given picture of showing how the IR sensor works. Now let's come to the advantages of IR sensor. It is low power consumption, noise immunity is strong, detects motion when the light is present or absent. These sensors are not affected by rust. They do not need to get in touch with objects for detection. No data because of the directionality infrared radiation of ray, and these are more modest in size and are more moderate. When the IR transmitter emits radiation, it reaches the object, and some of the radiation reflects back to the IR receiver. Based on the intensity of the reception by the IR receiver, the output of the sensor defines. Now, the advantages. Line of sight is necessary here, and it can be affected based on the conditions of the environment like fog, rain, pollution, dust, etc. These sensors can be blocked with common objects. The data rate transmission is not fast, range is limited, and high force IR signals can harm human eyes. Applications for rail safety, and it is used for IR imaging devices, infrared astronomy, optical power meters, sorting devices, remote sensing, etc. That's all. Thank you.